So this is, when we look at NFV, so what I mentioned earlier was that we actually have, from the device itself, has its own OEM portal to be able to do full lifecycle management. So this is when you first log into the device, this is basically what you'll see. So the first thing that comes up is you get a summary scenes, or summary slide, that basically will go through and say, okay, you've got X number of services running, how much resource out of the platform's capacity is allocated, and then you'll have some options that'll show, they'll start rolling, it'll show you capacity by this little dial thing, they'll tell you how much utilization is happening on each of the CPU cores. And then alongside will come our options for how we want to go in and configure the system to go turn services on. So I can go into the lifecycle management side, and actually let me go to one side first. Go to the deploy side. So when you first pull up, you'll basically get is a small topology drawing board, where now you can basically go out and deploy whatever type of network you want to do. So let's take an example here. We'll do something a little bit simpler. And let's say we want to go in and deploy a simple network. Service. Now let's, so I'll say we'll do is we'll go in and we'll deploy a virtual router in first. And select an image. So there'll be software images that will come first off either pre-installed or you can simply upload them. We'll also have other ways by which the software image comes onto it. You'll also have the ability within the metadata, and this will all be part of the information that gets published. You'll have many times where you'll have an individual service will have multiple flavors, meaning that I've got some amount of capacity that requires 1 core and 8 gig of memory and something. And then if I want to be able to double that, or for whatever the service's licensing requirements are, that says to get to that next one, you have to have 2 cores and such. So you want to be able to specify that in the metadata so that when you upload that package, that's now available, and you don't have to duplicate sending that image file up there every single time. And then for in the case over here, we got different license options. Now here's a nice little option. What we do is we provide a way to do a port forwarding. So you can reach the individual VNF on its internal network here by using the NFV IS IP address and then just simply doing a port forwarding. So let's give an example here. We'll we'll port forward SSH, and we'll send him over to 3322. And now we can just go in here and want to connect him up to the network, and we'll start him like him ID 1, connect 2. So now what we'll do is we'll put a firewall, and we'll put that firewall in line. So we'll connect up this side. 2 sides of the network. And we'll go back here, we'll do the same side, we'll give him his name. And we'll select his image. We'll leave it as that capacity. And now we want to go in here, for consistency, we'll keep him at the same virtual link numbering. And then down to here, 3. Okay? And now so we can have there, and we can also at the same time, let's say we want to go in here and we can put a WAN optimizer in place. His image, file, and then let's go in here now. We'll connect him up to that Ethernet interface, and now let's go deploy. So this process will take just a few moments. Actually, it starts going in, it loads in. Basically, for the Linux KVM, what we do is for our packaging is we use a QCOW2 image.
You can see why Open vSwitch is probably.
Sorry.
You use OVS on this, right?
Use OVS and as the switch, yeah. And when we use it though, and like I said, what it's being used for right now is really just basic bridge connectivity. Mm-hmm. We're not actually using any control plane sort of aspect of it. Quite frankly, that may change at some point. That's part of the reason we want to have that dependency. And also, since we are at times where we know we want to use specific types of hardware offload, in those cases, we actually would bypass OVS, right? In order when you run IOV, because it actually then goes directly from the NIC driver in the VM. Then talks directly to the Intel controller. So that bypasses it. So OVS would get bypassed as well. Okay. So let's go back now. We can go in and we take a look at our management side. So now we basically see our VMs are booting up for the 3 ones that we turned on. Actually, one's already coming up active. And so this now basically comes in. It's a very simple screen. We can actually go in here now. We can console into each individual device as well. Just pulling up literally to its internal serial port. Let's actually go take a look at one of these. And off he comes up, and so now that the ISR is booting up, and we go up to the firewall. And actually our firewall already loaded. It's waiting to go do a call home for its license. And then the file guy here. And he's up in his boot process as well. So each one of them will turn up. It'll take about 2 to 3 minutes. But you can actually see this. I mean, you're talking about now taking what was, a time as far as actually going and configure hardware, jack, RJ45s around, to actually now doing something where it's minutes. It's literally kind of gets down to that level. Barring, of course, WAN connectivity to actually push that software image. If it wasn't there, it would be a little bit. But other than that, I mean, that's literally where we sort of want to get to. Right?
And so I could build this as a template and then replicate this whole design multiple times.
Yeah, absolutely. So now, and we'll go over this a lot more with when Kishan and we go through the central orchestrator. But what we do here now, right, is that we take that package, and actually I'll give you a little more detail on this. Is we take an image file, and our spec is we want to use QCOW2 for the image file, and there's just 2 metadata files that specify things like how much platform resource it has, the number of profiles you want to have for it. I want to have like 3 or 4 flavors. And then there's a package file, which basically says, here's the other files that are in here. And it provides then an SHAI or SHA1 hash onto it so that the system will do a checksum when it gets the archive.
So in terms of provisioning, okay, once I build a package like this, I need to go and validate that, say, all the branches. I have 150 branches. And all of those branches have the necessary hardware to support this profile. Mm-hmm. You have tools to do that?
Well, once the core package is done, and it can have profiles in it, and those profiles some of them may not even be supported on maybe one device. So maybe you've got 150 branches in your example. And of those 150 branches, maybe you've got one profile that only works on 50 of them. That same one can still go out to all of them, right? You simply won't deploy it on those. But in there, when it extracts that package out, it will check the image file. It'll run the checksum to make sure that it all downloaded correctly.
That's too late. I need to make sure that the hardware supports this package because I want to deploy this package across all the branches.
Yeah, so let me. I think if you look at the ESA perspective, when we skipped over the whole plug and play and the call home. So what happens is when a new device comes on, you plug it in, it calls home, it registers with the Epic EM and says, here I am. And at that point, we have APIs to go query the hardware and say, what's your capability? How much storage do you have? How much memory? How many cores? And the orchestrator can go look at it and say, okay, this profile will run on your hardware before it starts pushing things out. So we have the ability.
That's the key part is
we have that.
Pushes it. Because I want to know that I need to go upgrade hardware before it actually happens.
Yes. This is the step you're talking about. Is when we do the orchestration is that comes up after that registration happens, when it does that first REST call down, the first thing it does is it checks for inventory.
Okay, let's back up to your other slide where you said, we already have a system deployed here, but what we're going to do is go and repartition this. Okay, so now I have a whole new deployment model I want to push out to 150 sites.
Yes,
How many of them don't support this because the hardware out there is limited somehow because it was Rev 1 of the hardware, and some of them have Rev 2 of the hardware? I want to know which ones don't work.
Sure.
Yeah, so I want to mention, again, I think I want to clarify that what James showed a second ago, that's a demonstration of NFVIS from a device level, right? Mm-hmm. I think in a few minutes you'll see how the enterprise service automation from the controller perspective can orchestrate multiple branches, and you'll see the steps of verifying the hardware before every change. Mm-hmm. And if you want to now change it, you can apply a new profile to an existing branch by either removing a service or inserting a service. And the profile will include all the necessary changes and the checks on the hardware and the resources before it's being deployed.
Well, we'll follow basically the same step when it's doing the orchestration piece.
I think my key point here is that I need to be able to go and validate that my hardware will support it before I do the push.
That's right.
Yeah,
that's right. And we'll show you how ESA does it in a second.
Okay, thank you.
So I have a slightly maybe deeper question that's maybe tangentially related, but on the NFV side, I mean, one of the challenges for many people that are going through audit controls for NFV is the fact that you actually don't have any in-band OEM that actually validates that everything is actually stitching through all the resources that you actually built. So you deployed 5 firewalls that is actually going through all 5 firewalls for that particular packet flow, and for this particular packet flow, it should only go through 4. And so part of the structural problem with NFV at scale for something like enterprises that are actually trying to control what's happening at their branches, how do you validate that? So do you guys actually have, I mean, Frank Borges wrote some pretty cool stuff for in-band OEM, but that's V6 only. What are you guys actually doing to validate what the packet flow actually is for the deployed services at the remote edge? How do you validate that to come back through as telemetry, right? Not analytics, telemetry. You need real-time remote telemetry to actually validate what's happening for those flows, because until you solve those two particular problems, you actually don't have any visibility about what's really actually happening at the remote branch. You just assume it works based off of modeling. Hopefully that's a fair statement.
So I'll start, and maybe I'll let our engineering folks here to add. But a few things. So first of all, James mentioned the health monitoring or the life cycle management in NFVIS. So that's a model that's first making sure that the VNFs are running properly, right? And then, and if there's any state that is not the defined proper state, it can either modify the controller to make changes to the flow if needed, or based on a policy that was preloaded into NFVIS, it can react automatically. So this is first from a VNF health and positioning perspective. Then if you look on the flow and how the flow works together, I think there's several ways that you can chain services together. We talked about the basic way, which is creating VLAN or bridges within the vSwitch. That's one way. There's another technology that Cisco has developed and also opened it up to the community called Network Services Header, or NSH, which is a service chaining software that enable you to use within the packet flow, add headers that can control the flow, and then infrastructure, which is NSH aware, and VNFs that are NSH aware can communicate on the status and where has this flow, which services has it gone through already, and what's left. So maybe you want to add? But
I think in the more tactical level, until NSH becomes broadly used by all VNFs, and I think that's a little times away. It's not there today, but it's happening. There's also the ability for us in that network diagram to create tap interfaces and be able to add, like a virtual NAM or the Wireshark or anything you want to every hop along the way. So you can get real-time data out of that. Right. Of course, that's some cost. As long as your WAN link can take all the data.
Sure.
But we have the ability, and in fact, even in the cases where we do hardware assist, we're making sure that what we can do with an OVS, we can do with the hardware too. So we have the ability of tapping.
But there's no planned inbuilt telemetry system today.
So there's I think if you're looking for you've got to have two models. If you want high performance, you cannot inject necessarily software into every packet flow and get that telemetry data out. If you're willing to validate the design, you can certainly take the switch model and do kind of packet tracing all the way through.
You can get the telemetry out if you have something like in-band OEM that Frank wrote, because it does just a service insertion and extension header. It pops out the other side. You validate it. You're done. That can be done without actually doing any software interrupt at all through the whole process. There's nothing that's equivalent in V4, right? So that's part of the structural problem.
That's my point. So I think when you look at V4 and say I need to have the ability of looking at what's happening on the wire at every hop, there is no easy way to do that, right? And so we can give you inspection points at anywhere in any of those interfaces, but not necessarily track it or trace it all the way through.
There's my argument for why you need to get V6.
Yeah.
and we'll do V6. And V6 isn't a problem. You can certainly do V6. There's not a V4 only solution. But I'm just saying you have to make it work for today's environment, and a lot of that is V4. And for that, we have the ability of kind of adding inspection.
Sure.
For example, one of the other software companies we've been working with that wants to run an application on our platform. Actually, what it is a cloud-based AVC application. So we're basically, they would take a first tap for all packet flow going in and out through it, and would then measure everything from application response time going through. Now that doesn't tell you necessarily every hop along the way, right, that it's actually getting there. And there's two sides of that piece. There's the first one that says that after I orchestrate from the very beginning, is everything up as I expect it to be up? In other words, did everything actually get built? Did somebody not, typo something or fat finger something and goes on? For something like that, we've been in discussion with some of the team that does the OEM build about having an initial trace route function that says that based on the profile that we deploy out, that it basically goes in and validates, number one, that the packet flow is actually hitting every type of interface. So it goes in there, reads it, detects that there's actually packet counters moving as part of that, and then also goes in and grabs, whether that be by a REST call or by SNMP, and grabs the data off the VM itself. So I can now correlate that data and says, yep, I entered it into the hypervisor and the virtual machine got it, packet trace is now successful, everything is up and working accordingly. So you can do that to some limited extent as long as you understand what the services are you're deploying. Sometimes you'll deploy things that are, like I said, some people as a custom application, and that's not necessarily some way you don't have an inherent way to be able to do that same type of tracing. But we'll continue to iteratively work that and make that evolve out better. But for the server side, we're certainly looking at doing some type of trace route for that, for the initial deployment. Then the second side is how do you do things on the ongoing side? And so we've looked at options around, like I said, if you're doing an internal tapping to be able to look at packet flows. If you want to do that either constantly or even just turn them up as a temporary service, monitor something you're doing, turn it back down, and then sort of go on. The other side is that there are some services simply by their nature of what they do. If you have that there, that can also tell you information with regards to what is what the amount of processing and handling time is. Web optimization, for example, basically embeds data in frames that sends things go when it does peering to leverage things like that. Liad mentioned as well, the other thing we looked at was we look at implementing NSH, where now the classifier now has the ability to receive that piece, and hopefully that's how we would implement it as far as some keep lives to the service function where it would divert to. And now it can say that, yep, I've gone on the counter, the metadata says I've reached him, his process came back. When the next guy came back, if I'm doing it by a full forwarding saying, my metadata is saying just go in and bop to the next service function forwarder, you can specify that metadata in there so that the final forwarding element can say, yes, I've got it, and it came via the other two services, and therefore everything's okay. Good.
Interesting point on the IWAN thing is basically what you're doing with IWAN is you're marking the packets. You're basically coloring them, if you will. A certain packet takes a certain path, different packet takes a different path, simply based on the IWAN criteria. Do a similar thing for tracing the packets through. Just color the packets, if you will, or mark them with some encapsulation ID so that you can track them as they go through. And then your tools like Wireshark and et cetera, whatever monitoring tools you have, can then grab those packets as they come by. I saw the pink one. I saw the yellow one.
Yeah.
This is exactly where
Then you can
Part of the
validate
challenge with service insertion with NFV, right, is the fact that you only know your determinate state at the time that you pushed it, right? At that point, if someone else does an additional service insertion, technically the controller understands that it's changed, but maybe your service rules for validating that don't. And then you have a difference that you have to deal with in terms of how do you actually audit and control that. That's really
Yes,
what it gets back to.
that's really the thing, is auditing it, not with traceroute, because traceroute may be showing, it may not be active enough data. It may not have the right tags in it for the right forwarding mechanisms to be used, whereas the real data does if you can just colorize the packets.
Right.
Yeah, and like I said, there are certain ways to do that. And as you look at a lot of different movements in the industry that may change what the ideal scenarios of how you want to implement that. But one of the things, for example, like what Liad was indicating, when you do NSH, right, because NSH is not just an implementation necessarily within a device, right? It's not just a packet diversion function, say, at one point. But I can have from my central controller my policy that says that my service path that I'm going to define is actually taking me, once I classify it, which if this would work, would come up to this guy, but also that same encapsulation forwards the data to one VNF here and then somewhere else, maybe it's going to a cloud application, right? And that can be specified all the way through, and then the reverse service path does it exactly the same way. So now I can go in there and I can associate metadata with the NSH header and do it almost to follow the exact same principle. There's also things like saying if I do MaxSec, right? Can I do things with or TrustSec doing things with the SGD tag, right? Are the ways to sort of leverage that side of it. IWAN, for another example, right? So you've got several times where you'll have potential of having maybe multiple overlay segments, and so you have to be conscious of that whatever you do doesn't inherently break something else too. But yeah, it's a good point that IWAN's an example of how to do that. All right, so Lord and behold, thank goodness, as we were doing our conversation, all those services are now, like these guys all come up now as being active. And now this portal now comes up and we can go in and see our resource allocation. So we come up and we've got, out of our 16 virtual CPUs, 3 of them are taking up one from each of the services and the associated memory. So again, sort of make this point clear is that this is the individual device portal. This is if you're connecting into them one at a time. We'll go through the central orchestrator here in a moment. But everything you see here, everything in here and everything you'll see in ESA are all done by a set of APIs that we expose. Right, so at the same time that all this data is there, other management applications, other things that we hope will actually also come up as well, can also now take things and say, hey, you know what, here's a valuable piece of information. How do I determine this? Right? I can go grab that information now through that API and now compile that with some other resources and make that, make that sort of assessment.
Let's say if we were talking about some of the management or monitoring type stuff, how do I detect drops in queues? Let's say they have QoS in part of this, of course.
So in the case of NFVS, what we do this now is the QoS is most likely implemented by a service itself. So in other words, NFVIS in our package is not queuing things, anything other than normal handling.
I mean, ISRV should be doing that.
Exactly. ISRV may, firewall may, will have will have an inherent amount of queuing right before it does, if it's doing things for DPI to make sure that the, the packet per second rise rate doesn't exceed the processing rate. So in those cases, each one of those service functions already have an inherent management capability that says, I've got packet drop or frame drop as a result of either a congestion or malformed frame, because there's a lot of reasons why it could be dropped out of queue. And those, in most cases, why I think we'll see that piece of the requirement on. I don't think there's.
So how were those exposed? SNMP?
In the case of IWAN, it's
Is it
not,
SNMP or REST interface?
so I can tell you. Well, I can tell you number one, SNMP is certainly one part of it. I know I have only looked at some level at the REST API in iOS XE, so I don't know if that's. I don't know if you have.
Yeah, so SNMP is definitely one way, right, where the current mechanisms that you use for ISR or for ASA or any of that, you can get to the statistics. And also we will expose the statistics from the service chaining perspective, the networking within the NFVIS, how many packets are sent by a VM and they're received by a VM, and if there are any drops there, those also will be exposed.
Okay.
And again, you can access all of this through the APIs that we expose, right? Whether it's RESTful API or through the Yang data models.
Okay.
So,
Cool.
yeah.